Hey problem solvers, Colfax Math here. Today we have another flow rate problem, excavating out for a new home. Compaction is really the most important thing, and to get compaction you need both water and a compactor. Unfortunately, we blew a valve or sucked the valve in on the water truck, so we're trying to figure out how to get water on the job site. And this video is going to be all about calculating flow rates to make sure we get enough water on this dirt to keep the dust down and get good compaction. So to get the dirt hard to drive over, I don't know if you can see where my feet are. To get it nice and hard, not fluffy, you got to get it wet and then drive over it with the compactor. And then here's the compactor here. So that thing vibrates around and then these things push in. So that compactor won't work unless you got a lot of water on it. So here's a water truck. I think it holds 1,500 gallons, and it's the perfect rig. But probably a blown valve on it. So this is out probably for a while. Then I have a hydrant hooked up to a 5,000 gallon tank on the hill there, but there's no power for the well down there to refill it. So that's the refill pipe, but it's not hooked up. So it's only gravity feed to here, 1.5-inch fire hose. So flow and pressure are correlated. If you increase water pressure, you increase the flow rate. In this video, I didn't want to get too crazy with the math and the science behind water pressure and flow. I just really want to calculate flow rates based on the amount of water and the time passed. So we have a trailer with the pump on it for discharging the water, and we're just filling it up out of that tank. The first try is with gravity feed out of that hydrant, and it's a 250 gallon trailer, and it took me about 40 minutes to fill it up. So that's obviously too slow, so I'm going to end up putting a 2-inch Predator pump between the hydrant and the fill up. So there's a suction hose from the hydrant into the 2-inch Predator pump. And then that red hose is a discharge from the pump into the trailer, and then we'll move the trailer to where the dirt needs to be compacted and shoot out of that. But I want to be able to fill that trailer quickly, and I'm doing that now with the Predator pump. And you could pretty clearly see how quickly the trailer is filling up using this Predator pump at full idle and no nozzle at the end to restrict flow. So the first case scenario is it took about 40 minutes to fill up that 250 gallon trailer. And now with the Predator pump online, it's only taking about 90 seconds or maybe 2 minutes to fill up this 250 gallon trailer. So let's calculate those two different flow rates. So here are the two flows, 250 gallons in about 40 minutes. The way you figure that out is you take the gallonage and divide it by the minute. So 250 divided by 40 is 6.25, or approximately 6 gallons per minute. Second scenario is 250 gallons in 2 minutes. So we could do it the same way and do 250 divided by 2 and get about 125 gallons per minute. Sounds about right. Let's say instead it was 250 gallons per 90 seconds. You could divide it by the 90 seconds, which is 1.5 minutes, right? So we do 250 divided by 1.5 and see this about 167 or 167 gallons per minute. So with that Predator pump in line filling up this water trailer, we're able to fill it up in a couple minutes and then get water out on the job site with no trouble. The pump going out of this water trailer is also a 2-inch pump, and it's doing a great job getting the soil wet, getting the compaction going, water and compact, getting that ground nice and hard so there won't be settlement in the future. So hopefully this video is informative. Please feel free to share with anybody if you're into the trades trying to figure out flow rates. Just a quick overview on flows, and I'm hoping it helped. I appreciate you watching. If you're new to the channel, think about subscribing, and thank you.